In 1920, market economists declared that a socialist planned economy was mathematically impossible because human planners could never calculate millions of interrelated supply chain variables simultaneously. Without market prices to signal supply and demand, they claimed any centralized system would collapse into complete chaos. Today, advanced artificial intelligence and distributed neural networks solve complex nonlinear optimization equations involving hundreds of millions of variables in mere fractions of a second. This technological leap renders historical claims about the computational impossibility of economic planning entirely obsolete. By tracking raw materials using Internet of Things telemetry, modern planning networks receive instantaneous data directly from extraction sites to factory floors. This continuous communication flow removes the systemic lag times and speculative bubbles inherent to capitalist market pricing systems.
Leonid Kantorovich pioneered linear programming in the mid-20th century to optimize factory output, but his radical mathematical methods were bottlenecked by primitive computing systems. Modern supercomputers easily scale his algorithms to handle entire continental supply chains. Vasily Leontiev developed input-output tables, mapping how industrial sectors rely on one another for production. Today, these massive matrices are calculated dynamically in real time, allowing systems to instantly balance resource dependencies and prevent cascading supply chain shortages. Algorithmic forecasting completely eliminates the structural waste of overproduction by matching factory output directly to real-time demographic metrics and localized consumption trends. Production becomes a precise science focused purely on utility rather than speculative corporate profit.
Instead of volatile fiat currencies vulnerable to inflation, economic value is calculated directly using hours of socially necessary labor time. Advanced computers track the precise human effort embedded within every component, establishing a transparent baseline for democratic resource distribution. Citizens receive digital labor vouchers directly proportional to the hours they work, minus standard public deductions for universal services like healthcare. These vouchers cancel out upon transaction, preventing the accumulation of private speculative capital or generational wealth. Predictive transformers analyze historical utilization patterns to ensure local distribution hubs remain stocked with necessary consumer products. By forecasting localized demand with high accuracy, the system fulfills human needs smoothly before specific individual requests are even registered manually.
Large-scale infrastructure investments like high-speed transit networks and medical centers are managed through democratic software applications. Citizens vote on projects directly, ranking public developments by collective utility rather than their capacity to generate private monetary profit. Carbon emission caps, water depletion rates, and soil degradation thresholds are coded directly into the core optimization algorithms as rigid mathematical limits. The economic plan cannot execute any production schedule that violates these fundamental ecological stability constraints. In the 1970s, Socialist Chile initiated Project Cybersyn, a pioneer real-time network for economic management. Modern systems scale this revolutionary decentralized concept using global cloud computing structures, rather than primitive telex machines and manual reporting loops.
Local worker councils log operational parameters and machinery status into regional network dashboards. These immediate localized updates continually feed back into the macro coordination algorithm, ensuring worker safety and workplace autonomy are balanced with required societal production targets. Complexity theory maps the planned economy as a massive directed graph, where nodes represent factories and edges represent resource channels. Network optimization algorithms run continuously to isolate potential structural bottlenecks and automatically reroute shipments before shortages manifest. Monopolistic logistics corporations already operate internal planned economies, utilizing proprietary software to coordinate global fulfillment networks without internal markets. A socialist framework repurposes these precise database architectures to maximize public welfare rather than private shareholder dividends. Market competition forces corporations to squander vast energy on manipulative advertising and artificial product differentiation. Digital plans eliminate this waste entirely, reallocating engineering assets toward maximizing product longevity, standardized modular components, and absolute ease of repair.
When automated factories increase manufacturing efficiency under capitalism, workers face mass unemployment and poverty. In a digitally planned socialist system, productivity gains trigger an automatic, uniform reduction in the required working hours for every single citizen. Scientific research is detached from private patent monetization and corporate secrecy. Advanced language models synthesize global scientific literature instantly, automatically directing public resources and lab personnel toward resolving urgent human crises, like rare diseases and environmental degradation. Global manufacturing networks require synchronized cross-border logistics. Neural transformers map international weather events and shipping channel bottlenecks, continuously rerouting automated maritime cargo fleets to maintain steady component deliveries to assembly centers across all continents. Automated planning algorithms remove human bias, nepotism, and bureaucratic corruption from resource distribution. Because the digital ledger is completely transparent and immutable, public officials cannot alter production statistics or clandestinely divert goods for personal advantage.
Urban housing platforms track architectural capacity and regional demographic shifts in real time. Living spaces are distributed equitably based on family size, accessibility needs, and workplace proximity, completely eradicating speculative real estate bubbles and corporate landlordism. Automated telemetry systems continuously monitor worldwide resource depletion rates. If specific mineral reserves fall below safe environmental thresholds, the planning engine automatically substitutes alternative synthetic materials and scales up local industrial recycling loops. Reinforcement learning agents simulate trillions of resource shocks and supply disruptions overnight. This continuous simulation process hardens national infrastructure against unexpected failures, creating maximum systemic economic resilience against crop blights, pandemics, or seismic disasters. Satellite imagery and subterranean moisture sensors feed agricultural algorithms that schedule optimal regional crop rotations. This maximizes food yields while preserving soil chemistry, completely bypassing the erratic financial speculation of commodity markets.
Pharmaceuticals and medical devices are manufactured using predictive epidemiological models. Regional hospital stocks adjust automatically based on real-time disease tracking datasets, preventing critical medicine shortages before seasonal infections can even begin to escalate. Industrial smart grids match clean renewable energy generation with heavy manufacturing loads. During peak solar and wind production hours, energy-intensive tasks like steel smelting and chemical processing scale up automatically to minimize carbon emissions. As economic plans adapt to new technologies, educational systems update training curricula dynamically. Neural networks identify emerging automated fields, matching workers with targeted skill upgrades, ensuring meaningful participation with zero structural unemployment across society. Public communication applications allow citizens to rate product reliability and suggest design changes. If satisfaction scores for a consumer tool drop below specified benchmarks, the manufacturing algorithm halts assembly lines until engineering revisions are integrated.
Transitioning to an algorithmic economy requires auditing existing corporate retail networks. By converting private supply chain databases into unified public asset inventories, the initial framework for a completely digital planned economy can be established smoothly. International trade operates through cryptographic clearing unions, replacing predatory currency speculation with balanced product exchanges. Exchange values are calculated using international labor time benchmarks, preventing the systemic economic exploitation of developing nations. Predictive maintenance models assess factory machinery degradation. Component fabrication and repair drones are automatically dispatched before mechanical breakdowns occur, securing stable production lines without the need for hierarchical corporate management structures. The ultimate sovereignty over the economic algorithm remains with democratic citizen assemblies. Large language models clarify complex input-output configurations, helping communities vote directly on major developmental goals, like space exploration or biome restoration.
Automated distribution depots utilize localized storage algorithms to balance inventory levels. If demand spikes unexpectedly in one commune, neighboring regional nodes swap surpluses autonomously without needing to wait for central administrative authorization. Unlike capitalist networks that use high pricing to restrict scarce goods to the wealthy, digital planning utilizes algorithmic triage during emergencies. Critical resources are distributed based on vulnerability metrics, prioritizing healthcare workers and high-risk areas.
Genetic allocation algorithms mutate and test millions of distribution pathways simultaneously. This mathematical process discovers highly optimized routes to transport food and emergency services, drastically minimizing collective transit energy expenditures across the nation. Under digital planning, the structural rift between market prices and real social costs disappears entirely. Every resource allocation decision is calculated based on literal, material, and human inputs, ensuring complete financial transparency for all citizens.
Advanced additive manufacturing and industrial three-dimensional printing networks allow consumers to customize standard blueprints via web portals. These custom design specifications are sent straight to localized automated fabrication facilities for print-on-demand delivery. Products are embedded with smart tags to track life cycle termination. When an item is recycled, automated sorting machinery disassembles the components, routing base metals and polymers straight back into active production loops with zero waste. Recent breakthroughs in quantum computation and combinatorial optimization algorithms make comprehensive economic planning feasible at a global scale. This development renders old free market critiques concerning computational limits completely obsolete in the modern era. Public transportation frameworks utilize real-time location tracking to adjust transit frequencies dynamically. This matches fluctuating passenger volumes perfectly, lowering urban congestion and eliminating the systematic necessity for private automobile ownership.
Local solar arrays and cooperative wind farms feed energy directly into a distributed smart grid. Autonomous routing tokens prioritize residential heating and community infrastructure before distributing leftover electrical current to nearby heavy industrial zones. Workplace environmental sensors measure air quality, noise levels, and machine vibrations continuously. If safety thresholds degrade, the central planning system automatically throttles production rates and schedules immediate maintenance to protect worker health. By automating the baseline distribution of food, shelter, healthcare, and public transit, the digital economy guarantees universal basic services to all individuals, removing the survival instinct from coercive market systems entirely. Software applications, artistic media, and manufacturing blueprints are classified as collective intellectual property. Free from copyright restrictions, open source code is universally accessible, sparking rapid collaborative innovation across all scientific and cultural fields. By merging advanced computing systems with socialist production relations, society moves beyond the market mechanism. This transition converts technology from an instrument of corporate surveillance into an open mechanism for true collective human liberation.